वो स्लाइड क्या करना
वो कर ली थी कर ली
नहीं आज भी आ रही है।
हाँ जी आमिर साहब आपको मेरी आवाज आ रही है?
जी बिल्कुल आ रही है।
तो आप अपना आप कैमरा ऑन कर लें ताकि हम
ठीक।
इसको शुरू करें। Bismillah Rahman Rahim. In the name of Allah, the most gracious and the most merciful. Greetings, everyone, and a heartfelt welcome from Pakistan Society of Civil Engineers here in Lahore, Pakistan. Whether you are joining us via Zoom or Facebook, we extend our warmest greetings to each of you for lecture number 66, proudly presented by our esteemed society. These lectures have become a cherished tradition since their inception in 2020, embodying our steadfast commitment to the dissemination of knowledge among engineers at every stage of their career. Each month, we embark on a journey into the latest developments of civil engineering, striving to keep our community abreast of the field's cutting-edge advancements. Today's session marks yet another exciting chapter in this ongoing pursuit of excellence. We extend our deepest gratitude to each of you for your presence here today, as your participation enriches our collective learning experience and strengthens our bond as civil engineering professionals. Before we proceed further, it is imperative that I acquaint you with the rules governing this webinar in accordance with the guidelines set forth by Pakistan Engineering Council. Now, I'm going to read out the rules. Registered participants for CPT points have to appear live on webcam. However, for ladies, there is an exception. If they wish, they can cover their face while appearing live on webcam. During the lecture, microphone of all the participants, except that of speaker, shall remain in mute position. At the end of the session, there will be a 20 minutes Q&A session. You can ask your questions at that time. And I would recommend that you keep on typing your questions during the lecture. And I would be noting down those questions. And at the end of the lecture, inshallah, I will ask those questions to the speaker, and he would be pleased to answer all those questions. Now, today's topic is outline of the design process of roads and utilities infrastructure for a site development project. And our guest speaker today is engineer Aamir Mahmood Ashraf. Right now, he is in UAE, probably Abu Dhabi, from where he is delivering this lecture. Mr. Aamir Mahmood Ashraf is a civil engineering. He did his bachelor's from UET Lahore, and he has also done postgraduate diploma in civil engineering. Mr. Aamir has more than 20 years experience in planning, design, and project management in the fields of transport, infrastructure, buildings, and land development. He has contributed to develop the transportation system and civil infrastructure in various cities such as Lahore, Islamabad, Sharjah, Dubai, Ras Al Khaimah, Riyadh, Yambo, Jubail, Muscat, Abu Dhabi, and Qatar. He is a strong advocate of applying holistic approach to development of civil infrastructure by considering sustainability, constructability, operability, environment, resilience, security, safety, and value for money. Some of the worth mentioning projects are General Cargo Terminal Oxagon Neom, Sharjah Safari Park, Kiada, Riyadh BRT, Qatar Education City, Ras Al Hamra Development in Oman, Dubai Hometown, Yambo Industrial City, Canayan Views, Islamabad, and Rural Access Program, Yemen. Currently, he's working as engineering manager in Jacobs UAE, a large consulting firm in the Middle East. Prior to that, he has served for several years in various design firms in both Pakistan and Middle East. So, ladies and gentlemen, this was a very brief introduction of our speaker, Aamir Mahmood Ashraf. And Ashraf Saab, the floor is yours. Kindly start with your lecture. Thank you very much.
Thank you very much, Tahir Saab, for a very nice and warm welcome. I really appreciate Pakistan Civil Engineering Society to give me this opportunity to discuss something which is like bread and butter to me, this topic. And I really appreciate the driving force behind this society, which is Rizwan Saab, Tahir Saab yourself, and Sadia Saiba, which are doing great job, in terms of providing this training opportunity for our field, for our civil engineering community. So with this, I will share my presentation slide.
Ji, Aamir Saab, your screen has been shared. It's perfectly working well. Kindly go ahead.
Okay, thank you. So as Tahir Saab mentioned, so the topic for today is outline of the design process of roads and utilities infrastructure for a site development project. So the learning objective of today's lecture is to develop a basic understanding of the infrastructure design process for a land development project. So we will not go into much detail. We will just discuss the overview of the design process, how we do the design of infrastructure for a land development project. And towards the end of the lecture, I will just touch upon some emerging technologies, some current technologies which are shaping the design process and which will become norm for the future designing process. So just a small disclaimer before we begin that this discussion is mainly based on my personal experience and will be quite general in nature. So which means that my current employer or any of my previous employer has no say on this. And also we are not following any specific guideline or reference for this discussion. Now, this before we delve into infrastructure development, so we just need to understand how we reach to this, how as a human society we reach to the current situation. So as we all know that we started off as hunters and gatherers, we just kept moving from one place to another in search of food and shelter. We just live in natural caves available to us. And then as we progressed, so we moved towards a more settled lifestyle. And that was made possible when we learned to do agriculture and we learned to domesticate animals so that, our food is available at our own place and we don't need to keep moving in search of that. And we are very proud that one of the greatest civilization, Indus Valley civilization, was located just where this beautiful homeland Pakistan is. And we have, Harappa and Mohenjo-daro as, which shows us that how advanced those civilizations were, in terms of the urban layout, the drainage system, the bathing facilities. So if you can see this picture, you can see that, this pool is available, and, this very meticulous layout of urban layout was there. So this shows that how our field of civil engineering, our profession of civil engineering, is helping develop human civilization. So this is not just our profession. This basically is very key to the human development. So we should a little bit feel proud because of that. So when we talk about basic human needs, so we can see that our basic human needs are like shelter. So we need to save ourselves against harsh weather, against external threats. And then we need mobility. We need to move from one place to another to do one activity, because all the activities are not.
Aamir Saab, your slides are not moving somehow or the other.
स्लाइड शो पे आ रहे हैं, वो स्लाइड शो पे नहीं आ रहे।
So I think this slide was visible or not?
No, I think you have to start from the first slide.
Okay.
See, I was looking
Okay.
somewhere else, but I did not notice that the slides are
No,
not
no
moving.
issues, no issues.
Thank you. Now
So
you can
as I just said earlier, so this is our topic for today, outline of the design process of roads and utilities infrastructure for a site development project. So I just mentioned earlier that our learning objective is to develop a basic understanding of the infrastructure design process. So we'll not go into much detail. So we'll just have an overview of this whole process. And towards the end of the lecture, we will also get some introduction of the emerging technologies which are shaping the design process. And just a small disclaimer that this discussion is based mainly on my personal experience and is quite general in nature. So, I mean, it's not related or not, we are not following any specific guidelines or reference for this. And also it has nothing to do with my current or any previous employer. So I just spoke about that, how we reach to the current situation where we need infrastructure, where we are talking about infrastructure, because we have, there's a long journey we have done as a human species, a human being. So we started off as a hunters and gatherers. So we just kept moving from one place to another in search of food, in search of shelter. So we were not stationed at one particular place, which we now call city. So we were living in caves. Then as we learned to, how to do agriculture and how to domesticate animals, then we have more like a settled lifestyle. So we developed, okay, we will stay at this specific place only because this is very nice, and all other things we can work around. And as we all know that in our part of the world, in Pakistan itself, we used to have a very great civilization which we now call Indus Valley civilization, and Harappa and Mohenjo-daro are the two main cities which we all know about. So these civilizations have very meticulous urban layout, a very effective drainage system, which even I saw in the newspaper that during some current rains also it worked very well. And they have bathing facilities. So these developments show that at that time also someone wearing our shoes like civil engineers, so they were there to design and to construct and to operate all these facilities for the people. So this makes us feel a bit proud that civil engineering is not just our profession, because this is closely related to the civilizations, to where we are now, and in future also. So we have a very positive role, a very key role in that sense. So when we talk about basic human needs, so what comes into our mind that, okay, we need shelter. We need shelter against harsh weather conditions. We need shelter against our security against, external threats, maybe animals or whatever at that time. And then we need mobility. We need to be mobile. This is our basic human need. We can't just sit at one place. We need to keep moving from one place to another for certain activities, or just even for leisure, for fun. So we need, this is our one need. Then water, without water, there is no life. So water is our basic human need. Energy, we need energy. We need energy to cook our food. We need energy to keep ourselves warm in our homes, to light, for lighting, for ventilation. So energy is our basic human need. Then we need to communicate. We can't just sit alone. We need to communicate with others. We need to express our feelings. We need to express our ideas. We need to express our thoughts with others. So we need to communicate. So communication is a very, and right now, with as the technology has advanced, as we can all see, that now we are all sitting at different geographically dispersed places, but we can communicate as we are sitting just close by. So this communication is a basic human need, but how we meet it, so that keeps growing with time. But when we can talk about, giving this brief introduction, now we can talk about physical infrastructure. So this is where this physical infrastructure, which helps us to meet these basic human needs. So this is happening in the background, basically. So if I just read this slide, so physical channels that connect one space with another, enabling the passage of peoples and goods. So like all the physical connections which we have in terms of roads, in terms of bridges, in terms of railway lines. So these are all physical channels which connect peoples and goods. So we can, go from one place to another. We can, transport goods from one location to another. And also, if you see this, another way of looking at it is technical system that create the skeleton of urban life. Transport, telecommunication, urban planning, energy, water. So all the skeleton of urban life, so which makes our city, our life in city possible, is because of this physical infrastructure. So that the interesting thing is that it remains in the background. So we because this is only, okay, the roads are mainly visible, but all other main utilities remain underground. So we are not aware of it. But we all know that, okay, when we open a tap of water, so the flowing water comes all at once. Or we just, click a button and, it switches on a button. So all of a sudden, we can illuminate our space. But there is a physical infrastructure which is making it possible, So we will talk about that now. So this infrastructure is basically what we will be discussing, and this infrastructure which runs in the background and which makes our life possible as a city dweller, as a city inhabitant. So this provision of infrastructure requires a multidisciplinary approach. So it's not just one discipline. There are a lot of disciplines involved which interact with each other to develop this infrastructure for us. And it's a multi-stage process. So it goes step by step. So the key main steps, as we all know, is design, construction, operation. But as of now, we will be discussing the design process and outline of the design process. So we'll be just focusing on the design aspect. Planning. So for any design or any activity in life, we first start with planning. And as they say, if we fail to plan, we plan to fail. So planning is very important. So planning is where we define what we are going to achieve, and the overall structure of how we are going to achieve that. So in planning for an infrastructure development, there are some key things which I just jotted down here. Data collection. So whatever the available data is there regarding that development or regarding the associated area or the overall, giving us the overall scenario for that area, that city where we are going to have that development. So all that data available from various authorities, we need to collect that. And we need to sift through that and find what is available information, what is pertinent to us, what is helpful to us. And then, of course, investigations and studies. So some of the investigations may be already done by, during some previous phases of the project. But again, if that's not sufficient, we have to go through all that information, and we have to, do some investigations and studies on our own also, if that required. Like, for example, topographic survey. So we have to do the topographic survey of the area, the geotechnical study, to understand the soil characteristics. the hydrological study to understand the drainage pattern of the area, the rainfall intensity of the area. Environment study. So what are the existing flora and fauna or any heritage? So we need to understand that so that we take into account all these things. And again, those studies will also advise us, what we need to do, or what we need to consider in our design, what we can do, what we cannot do. I mean, so all those studies. And traffic is very important, traffic study. So again, all these at the planning stage, maybe as a designer, we are not directly involved, but there are our input is required to produce transport master plan, infrastructure master plan. Of course, there is urban master plan also, but I'm not putting it here. But these two are very important for us to understand, because all our design, these will become reference of our design. So all our design needs to align with the transport master plan, with the infrastructure master plan, because here is one where the overall strategy has been defined, not just for our development, but for the overall area, so that, it's consistent with that. Then, of course, we need to take into account, or these should always be in the back of our mind, these overarching principles, which are always, are like design constraints for us, you can say. We need to define our limits, our boundaries. So we need to be to remain inside those. So these are codes and standards. So there are, of course, some global codes and standards, but of course, more we need to see what are the codes and standards applicable to that particular city, that particular location. So those needs to be followed. And of course, sometimes there are deviations, but those deviations also needs to be agreed upon. Then compliance with authority having jurisdiction. So these utility services, they belong to certain authorities. So they basically, okay, maybe we will be designing those, we will be constructing those, but ultimately those will be operated by certain authorities. So those authorities have their own, conditions or their own requirements. So we need to understand those, we need to comply those. And of course, as a process of design, we need to get their approval, or NOCs, as we say. So interdisciplinary coordination is very important. So this is something, we cannot do in isolation. We cannot do, as we say, in silos, we need to coordinate with other disciplines, and it's the final product is the outcome of, involvement of all the disciplines. Then quality assurance. Quality assurance is very important, because we cannot just keep doing the design and then ultimately at the end of the day, we know, okay, this is not accepted by the client for some reason, or this is not good enough. So we have to follow through a process, a review and approval process. And we have to have a very well-defined quality assurance procedures, so that we go step by step. And because ultimately we are working for a commercial entity, so we don't have we have a limited budget to do our design. So we cannot, go for infinite iterations of design. So we have to see that, okay, we finish one step, we review, we get approval of that, then we move forward. And that's how we, at the end of the day, we get a product where everybody is happy with, and there are no surprises later on. So in terms of design components of an infrastructure development, we can broadly break down into grading and drainage. Then a very key thing is utilities disposition and road right of way. Then of course, road network, and wet utilities, dry utilities. So by wet utilities, we generally mean pipe networks like water, wastewater, irrigation. Dry utilities are cable networks like electrical, telecom. So that's also sometimes, we split these utilities, wet and dry. So wet utilities, as we know that this again is designed by civil engineers, but dry utilities, of course, we need electrical and telecom engineers. As I just said that, okay, this is an interdisciplinary work. So basically that means that we work in an organization, we work as a team. So, they say that, we have developed, I mean, the human being have been able to develop what we have developed so far is because we have learned to work as a team. So, I mean, if we just work in isolation, maybe we would not been able to achieve that much. So now we don't know, I mean, as an individual who worked on this, but we all know as a team that, okay, this team was responsible for this design. So that has actually helped us to achieve what we could not have been able to achieve if we had worked individually. So, I mean, broadly speaking, this design team for an infrastructure project is led by a project manager, supported by a design manager. And then, if we just see the main disciplines or main team sub teams are basically grading and drainage. So this is one team. Then road design is another separate team. Wet services is a team doing all the wet services. Then electrical and street lighting we have. Then telecom and this civil structure. So okay, these disciplines we already talked, but of course, there are associated structures also for these services, like for example, manhole chambers, or even the duct protection. So then again, we need someone to look after that discipline. So we have our civil structures team to look into that design component. So as I just said earlier, that infrastructure design is done in stages. So these are like the 4 main key stages which we follow. Concept design, which is like, sometimes we call it 30% design, preliminary design. There are, I mean, different nomenclature also, some where it's called developed design also. So it's 60% design, then detailed design 90%. And ultimately we issue a package which is straight away goes to contractor for construction, issued for IFC. Of course, there is, issued for tender also, but I'm just skipping that part. So tendering is another process before we go into construction. Now, basically, why, as I just earlier said, also we need these stages so that, we keep on fixing the basic thing, so that we don't need to go back and, open another discussion. Like, for example, okay, as it's a multidisciplinary approach. So, I mean, if we change anything on our own, so it will affect other disciplines. So even, like, for example, in concept design stage, we need to fix the right of way, because this right of way is allocated to us to design our services. But of course, there is an urban plan by urban planning team. So if we later on go to them and say, okay, we need another meter here or another pump station we need to locate, so it will create a lot of mess, So I mean, it will become very difficult for them to even allow for that. So we need to, basic things, we need to keep fixing those, and get buy-in from all the stakeholders, from all the team, from the client, from all the disciplines, so that we agree on concept design. Then we further detail it, we further refine it to the preliminary design. Then it's again reviewed and approved by the client, and by interdiscipline checks are involved as well. Then we move to detailed design, where we further refine it, we further detail it, and then ultimately we issued for construction, where all the constructability issues are resolved, and all the details are there, all the specifications, all the data sheets, all the that details which are good enough for any construction company to perform construction activity. So this slide is very important, because okay, this basically explains the whole process. Like, for designing any service, any utility, any infrastructure service, we need to take into account these things. And this applies to all the services. I mean, this is not specific to any particular discipline. So we need to understand the existing conditions for that particular service, for particular discipline. We need to understand the interface arrangements. Okay, we are not okay, we have a piece of land, but of course there is an associated area with that. So we need to see how that interfacing is with that adjacent land, with that adjacent developments. So that's also very key for us to understand. Then demand estimate. Of course, you know, even for traffic, for water, for electrical. So we need to understand what is the demand, how much water is required, how much power is required. And that mainly we need from the population estimate or from the gross floor area estimate. So this is where we need to understand what is there in the urban plan, what is the land use plan for that area. So that's where we get that information about population, about area, and based on that, we have our criteria and we develop how much is the consumption, how much is the requirement per capita or per square meter, and based on that we estimate demands for those services. And then we have to have a design criteria. So how we are going to design that service. So we need to have a very well-defined design criteria for that. Okay. And this basically needs to be developed well in advance, and it should also be approved by the client or by the reviewing authority. Because later on we will be checked against, our design will be checked against that design criteria, that we need to exactly follow the design criteria. Okay, if there are changes, of course, there is a process. Of course, change is a constant thing. I mean, there is nothing constant than change, but of course, there is a process for that. And we need to escalate if there is any change, but we need to, as much as possible, follow the design criteria. And then there are calculations involved. So we can simply call it network analysis, because ultimately it's a network of links and nodes, whether it's pipes, whether it's roads, whether it's cables. So it's a network. So we need to analyze the network. We need to see that whatever the pipe we are providing, whatever the cable we are providing, whatever the road we are providing, that is enough to cater for the demand. The capacity is there to cater for the demand which we foresee on that link. So that's we do the network analysis, and after that, of course, we propose the system. So we use certain software for this activity, for the design activity. So some of the very popular software in this part of the world, I just mentioned here in this slide. Autodesk AutoCAD, Autodesk Civil 3D. So for drafting, we generally use AutoCAD. For modeling, 3D modeling, it's Civil 3D. Then these three are for wet services, wet utilities modeling: WaterCAD, SewerCAD, StormCAD. So as we can say from the name, you know, it's for potable water, for wastewater, for storm water. And of course, there are plenty of others. And I haven't mentioned, you know, what we use for like street lighting, for electrical, for telecom, because these falls into domains of our electrical and telecom engineers. So things keep changing. You know, when I started my career, you know, it may now feel as a joke, but at that time, you know, we were having manual drafting. And then during my career, you know, within I think 5 to 6 years, you know, there was a sea change when we switched to AutoCAD, you know, and this whole thing of you know, drawing boards and manual drafting became history. So I'll come to this towards end also, but this is very important for us to understand that things keep changing. So we need to be abreast with the changes, and we cannot just stick to our old way of doing things. Now we'll start discussing this into a bit detail, this design process. So I just mentioned earlier, that's road right of way and utilities disposition, because this is very critical. That these needs to be solved at the very beginning, you know. So we need to have a road cross section. Okay, so basically, as I just said earlier, that as an infrastructure team, we are just allocated a corridor between building lines. So that is our where we can just work, you know, all beyond the building lines. So this is out of our area, you know, we cannot encroach into that. So that's why we need to be very specific, and we need to work very clearly on our right of way, so that later on there is no issue to us. So this basically, when we develop road cross section, so we have to understand road hierarchy. So this hierarchy basically applies to all disciplines. So if in terms of road, of course, there is a hierarchy that, okay, there are freeways, expressways, then there are, you know, arterial roads, then collector roads, then local roads. So each road type has its own cross-section requirement, which basically we use while developing cross-sections. And there are authority standards also. Some authorities have their own specific standards. So that, I mean, this is because, okay, we are developing one part of the area, but of course this belongs to the whole city. So this needs to be consistent along whole city. So we have to take into account those standards also, like for example, lane width. If it's 3.65 the authority is using, so we have to be consistent with that. Some other components like this. Then as I just said, this right of way and road cross section needs to be coordination. We need to coordinate with the urban plan, because this is something we are interfacing with them. Traffic requirements. So how much traffic we are anticipating. So this information will come from the transportation master plan or the traffic impact study, which we just mentioned earlier. But again, you know, okay, we are used to talk about roads, and we used to talk about cars only, but roads are not just for cars. We need to think about inclusive design. So there are other very important, crucial road users. We need to consider pedestrians, cyclists, you know. So this is very important, that we just not do design for one specific road user. And then if we talk about utilities, so we need to allocate corridors for each utility. Okay, this corridor is for potable water. This corridor is for storm water. So specific corridors are allocated. And of course, it's not like we do it in one go. So there's a lot of to and fro discussion between various disciplines, because they have their own specific requirements. And then again, you know, as I discussed earlier, so there are authorities. So authorities have their own requirements. Okay, they for example, if you talk about power distribution company, so they say, okay, our power distribution line should be that far from the gas line, or it should be vertically separated from whatever, you know, sewerage line or whatever. So these all iterations we need to consider, and we need to develop a cross section for the utilities and for the roads, which is acceptable to all. And we cannot, you know, because land is a scarce commodity. So it's a limited land available to us. So we should always try to have efficient usage of the right of way. We should try to have minimum right of way, so that I mean, it's not that and of course, you know, because there are a lot of interaction with others, so they will always keep pushing us, okay, to minimize right of way. So ultimately, you know, we will reach to a optimum design. And optimum, as we keep discussing, so this is very, you know, mantra for civil engineers. We always go for optimum design. So this is just one slide which shows a typical road right of way and utilities cross section. So you can see this is median, this is carriageway here, this is a street lighting pole along with the tree line, the landscaping strip. Then we have a sidewalk here. Then this is side slope, and then, you know, for this is major collector road. So we can see they have the open channel for storm drainage here. And underneath, you can clearly see that, you know, we have various utility corridors. We are showing not just the utility lines, but also, the chambers for or the manholes for those services. So again, you can see that there is no service underneath the carriageway. So this is again some specific requirement for that particular development. But sometimes, some authorities allow certain utilities to be under carriageway. So in that way, we can compact our cross section. So so mainly, those utilities considered from the maintenance point of view. For example, we cannot allow any pressure line, potable water line under carriageway, because if there is some disruption to that, again, it will be a big problem to open it and to but of course there are some utility lines like stormwater, which doesn't require much maintenance. So I mean, and sewer line, so those can be kept under carriageway. So this is for the major collector road. Then we have another cross sections for some lower category roads. Now we will briefly talk about grading and storm drainage. So grading and storm drainage go hand in hand. When we have a virgin land, a natural land, so I mean it's a lot of hills and troughs. So we cannot develop any development there, because we need some smooth surfaces there. We need some gradual slopes, I mean, to develop our development. So first step would be grading of the area. So we need to grade that area so that later on we can go for our development. And grading also needs to consider the storm drainage. So storm drainage, okay. So grading also needs to consider the adjacent area. So there may be an overall drainage plan, so overall grading plan for that area. So we need to tie into that. We need to consider that, and we need to follow that. Then we need to see where we have the drainage outfalls, where we are discharging the storm water. So those points are very important for us while designing the drainage. So we need to follow that. And optimization, of course. Optimization is our bread and butter. So we cannot, all our designs need to be optimized. So we need to optimize earthwork quantities, because every cubic meter, costs us money. So we need to do value engineering so that, there is no extra earthwork required. Now, in terms of storm, of course, I just mentioned here that, recently there was a large storm event, rainwater event happened in Middle East. So we cannot, we have to, during design, we have to have a design storm event, like for which we are designing this infrastructure. Because everything has an age, even infrastructure has an age. Like we are designing some pipe network, let's say, for example, for 20 years, 30 years, 50 years. So stormwater network, for example, like open channels, maybe we are designing for 50 years, but maybe pipe network, it itself has a life, So we need to consider the probability of a design storm happening during that design life. So this is, and of course, all components are not designed for one specific design event. So maybe, as I just said, pipe network can be designed for 1 in 10-year storm event, open channels for 1 in 50-year storm event. So, but all these needs to be defined during our design criteria, and so that later on we can prove, or we can validate that our design is designed based on this storm event, and yes, it fulfills that criteria. And but nowadays, we all know that there is a lot of discussion about sustainability, about climate change, resilience. So basically, so that is something we all need to know, because we cannot just design our network, design our system just based on our analysis, based on engineering principles, based on our mathematical modeling. We need to consider all these socio-economic parameters also. So this is one term coined for which is used for drainage is SUD, sustainable drainage system. I mean, I'll not go into detail because this is not also my specialty. But overall, I would just say that okay, we have existing land, natural land, virgin land. Of course, there is an existing drainage pattern for that. When there is a storm water event, so some of the water it holds. There are some low areas there, and of course, then some water flows out of that area. So basically, in nutshell, we need to replicate that. We need to see that okay, our intervention, our this development should not affect that drainage pattern. So I mean, we should try our best that whatever the existing drainage pattern was, so more or less we remain close to that. I mean, whatever the storm water was discharged as a virgin land previously from that part of the land, so this should more or less remain the same, so that we don't adversely affect the environment. So this is one layout showing the grading and storm drainage layout. So you can see these are the proposed contours. So if I can read, so this you can see 11.25, 11.5. So this is a low point, and this is raising 14.3, 15.25. So this you can see this is the high point here. So basically, and then again 17. So this all is raising 19, 20. So this is the high point. So you can see that this whole is flowing towards this side. So okay, so basically this area was close to sea, and this this towards this, which was towards this side. So basically, yeah, that makes sense that we will draining to this side. Otherwise, we have to split. So we have to have like mostly we have to a high point here. We should drain to this side. We should drain to other side, and we can have accordingly have our discharge point. So again, because this is external existing road network. So our part is only this internal area. So again, this drainage, we need to see that okay, this must be a drainage outfall there where we are draining. There may be an open channel here. Yeah, existing. You can see there is existing stormwater channel here. So we are discharging to that. Now we will talk about road network. So road is we all know about road, because road is something which is above ground. I mean, it's very obvious. It's known to even common people. That okay, these are the roads. Other utilities remain hidden, so we are not very much aware what's happening to them. Road basically two main design parameters are we need to consider. One is the design speed, and the other is the design vehicle. So all our design criteria is based on what design speed and what design vehicle we are using, or we have assigned for this road. So design speed will advise us on the side distances. Side distances basically provide us the for a driver to comfortably stop before any hazard, so that it doesn't clash with another vehicle or any other obstruction. So basically, based on those side distances, we design horizontal and vertical alignment. I mean the grades and the curves which we design for that particular road. And design speed basically is defined based on the road category, which comes from, again, this transport master plan. Okay, for example, we can easily see that, okay, freeways have a higher design speed, And there is another relation between design speed and posted speed, but again, because our design is mainly based on the design speed. Then of course, design vehicle, because if there are local internal roads, we are using a smaller design vehicle, but for external roads, for freeways, for highways, for arterials, so we expect, a large design vehicle. So we need to design our geometry, road geometry for that. So basically, design vehicle we will use for like the turning radii, for how that vehicle will maneuver, a curve, or so that we should ensure that our design vehicle should be able to maneuver those curves. The analysis, what generally we do, like there is a visibility analysis for side distances, and again we do swept path analysis for the design vehicle. And there are softwares available which help us. We can just simply use them to see whether our design is sufficient to cater for that design vehicle. So some of the very popular softwares like AutoTurn, AutoTrack are there in use. Then of course there are intersections involved, so we need to design intersections. Again, we need to refer to traffic study and traffic engineer input for that, because there is these capacity analysis is done for these intersections. So we need to know what is the traffic volume involved. So based on that, even the type of the junction, whether we prefer to have a roundabout or a four-leg junction or a signalized junction. And again, this also we need to have input from the urban planning team, because how they are visualizing this whole development. Even the landscaping team, how they are looking into this. So again, this multidisciplinary approach comes into play. So again, we need to see, okay, how many additional lanes are required at the intersection. We need an additional left turning lane or right turning lane, and even the length of that right turning lane. So that will come from the capacity analysis, but we need to ensure that the geometry, is right for that vehicle type and for that design speed. Then another component is pavement design. So pavement design is basically where we establish the thicknesses of various layers of the pavement. Even sometimes we decide about whether we are going for a rigid pavement or flexible pavement, but mostly it's flexible pavement, asphaltic roads. So what are the various thicknesses for sub base course, wearing course, asphaltic base course. So all these needs to be designed based on the traffic volume. And again, traffic volume, we need to refer to the traffic studies and soil characteristics, CBR values, which we refer to, of course, geotechnical investigations. So, and again, optimization is always our key consideration. So even a small, reduction in thickness can save a lot of money. So we need to be very, very careful in designing our pavement. And then one major component is our traffic control plans, where we design what kind of signage is required, what kind of marking would be there. And there are, of course, standards and codes, so that there is a consistency and uniformity for that city or for that country. Because this is the language which the driver will read, and based on that they will drive their vehicle. So stop sign, the yield sign, the speed limit signs, the center line marking, the shoulder, the stop line. So all this we do as a part of signage and marking design. So this is just one layout, one very large layout, which shows the road. This colored one basically is our design part, and all this is our external road which we are interfacing with. So if you can see that only we are connecting to this intersection here and these two intersections here, but at all other locations we are just providing cul-de-sac. We are we are not connecting directly to the main road. So this also comes from the transport studies, traffic studies. And of course, we know that there are other traffic related issues because there should be some minimum distance between junctions. We cannot have closed junctions. So this we can see is a cul-de-sac here. So all the vehicles have to turn around and only they can access this road from this junction. And if they have to go out, so this is their way out, So this is something just I want to highlight. So with this, we move to potable water. So again, this is an overview. So I'm just sharing some of the key issues which I encountered during my experience. So it's not like we are doing step-by-step process for design. And again, if you allow me to go back to this slide. So this, again, I would emphasize that this applies to all disciplines. We have to understand the existing situation. We have to understand what are the interfaces with the adjacent development. We have to estimate the demand. We have to establish the design criteria. We have to do our analysis, calculations, and then accordingly, we propose the system. So this more or less applies to all these services, infrastructure services. So here, basically, I'm just sharing some of the things which to me are very important. So just I want to highlight that for potable water, demand estimate is based on the population. So from urban plan, from the urban master plan, we understand, okay, how much population is going to live in that area. So that figure tells us that, okay, what is based on our design criteria, per capita demand. So we can estimate, okay, this much water would be required for this development. And again, I'll not go into detail, this is basically on the average water demand, because water demands keep changing along, not during the day, during the week, during the year. It's not a fixed thing. In the morning we need more water, and when everyone is out of office, out of home, so there is no water usage. Similarly, during hot weather we need more water. During winter we need less water. So this demand keeps varying. But of course, there are certain ways of doing this. So we basically averaged out, and certain components we design based on average demand. Certain components of our system we design based on peak demand. So, but this is more of a detailed thing, and we'll not go into that much detail because we here mainly just having an overview. And then pressure and flow at supply times. So not only pressure and flow, what we are be getting at the times, where we are going to tie into our network to the external network. So what are the flows available there? What is the pressure available there? Because that will become basis of our network design. Because this is our constraint, we cannot change what's already there. Okay. Something, yeah. Basically, during data collection, because this is an existing situation, but of course, maybe the authority has an upgradation plan coming up soon. So we need to understand that, okay, they have a plan of having a future tie. So we need to understand the timeline for that, and accordingly, design our network, our system to utilize that upcoming facility. But again, sometimes if we don't meet the requirement, then we have to look into the storage requirement. We may need to have internal some in-house storage for our to cater for our demand. Just hydraulic analysis or the network analysis we earlier said. So generally, we know about steady state, which is like most of the time our network is running on a steady state, and we design to cater for for that state only. But again, there are some extreme scenarios, like maybe some pipe is busted, some valve is closed for some reason, or malfunctioned. So this may impact downstream upstream chain of events. So this can even jeopardize the whole system. So we need to do some surge analysis for that, and we need to provide some protection measures against those untowards incidents, against those extreme situations. So this is also very important to know. And then again, just when we design, come up with a system, so it's mainly pipe sizes, valve locations. So this is more or less what we can get out of this whole exercise. So this is just one layout for the same development. This is the potable water lines. So they are in their own specific corridor, and there are some walls and chambers. So if you can see here, so pipe diameters are mentioned, and then at some locations we have to cross to the other side as well, because okay, this distribution line is on one side, for example, but of course we need to supply to the development on the other side of the road. So we need to cross that cross that road. Again, we can, if we go back to the where we define the utility cross sections. So again, we need to see, okay, if we, for example, if we have a water line, whether it should better to have on this side of the road or on the other side of the road, or so this kind of things also we discuss and agree upon during that stage, so that later on there is smooth sailing, and there is no like we need to go back and change our utility disposition. Now, wastewater. So if we are using water, then of course that part of that water only gets evaporated or used by us. The rest becomes wastewater, and we have to discharge it. So mostly, like if we talk about, then I think 80 to 90% of the water, which potable water, goes into waste. So to understand the demand for the wastewater, when we know the potable demand, so I mean we can simply say that okay, 80-90% becomes the wastewater. So again, for wastewater, we have to see the disposal tie-in capacity. So where we are discharging this to the external network, to the external system, what is the available capacity there? Can we discharge our wastewater there, or we need to do something else? Sometimes these issues become showstopper. I mean, if we can't discharge, so I mean it's very difficult for us to continue with that project, to continue that development, unless there is some external plan or external upgradation coming up soon. Okay, wastewater can also be, we can think of in terms of gray and black water. So this is where we were thinking about, again, from sustainability point of view, because again, water is a limited resource. Water is a scarce resource. So we cannot just let it waste. So we need to think about it that, okay, so gray water is mainly, which we use for washing, for wash basins, for bathing, but there are like black water, which is from our WC. So we can try to think to separate them out, because they have their I mean, gray water can be used again, can be reused for like flushing toilets, for example. But again, there is an issue that we have to have a separate distribution, a separate collection system for them, and this only not at the infrastructure level, but at the building level also. So, but again, this I just put it because this is also something being discussed nowadays. Then holding tanks. Okay, so we have a limited capacity to discharge our wastewater. So what we can do in the meantime? We cannot discharge, especially at the peak time. Again, wastewater flow is not like continuous. constant flow. So it keeps changing. There is a peak flow. There is, then similar to the potable water consumption. So there are ways, we can provide some holding tanks, where we can hold sewage temporarily. Of course, we cannot hold sewage for a longer duration because it will become septic. But like, for example, for let's say 1 day, we can hold it, and then we can discharge it during off-peak hours to the external disposal point. So these kind of things we can also think of. And as I just said, reusing gray water. Now, water is a limited resource. Water, it's a precious resource. And as someone said that maybe in future, wars would be on water rather than on geographical, land issues. So, okay, unfortunately, in Pakistan, I mean, we are not treating the wastewater the way we should do, because of I think the mainly because of the capital, because to develop a sewage treatment plant is quite capital intensive. But this is very important. And again, okay, we generally, in this part of the world, we have large sewage treatment plants, and of course, there are pros and cons for that. But again, we can start thinking of having localized treatment even at the building level. This is something will help us in long run.
Aamir Saab, I have to interrupt you here. There is a pertinent question. I think you would like to answer it right here. It's from Ridwan Mirza. It is, why, as you have mentioned, different return periods are adopted for different design parameters?
Okay. So this is related to stormwater system, Rizwan Saab, if I'm correct. Okay. So basically, as I just said, that there is a design life for a facility also. Like, okay, pipe network, a road network, there is a specific design life. So we cannot design all the components of a drainage system for like 1 in 100 years. Okay, we can do that, but of course there is a cost associated to that. And we have to optimize the design, and we just can't unnecessarily build something which is not utilized later on. So okay, if we have resources, if we have money, we can think in long terms. But again, this is pipe network. So okay, maybe this is going to be replaced anyway after 20 years, after 30 years. Pipe have their own life, so we don't need to unnecessarily design it for 100-year waters storm. But of course, if in terms of open channels, in terms of culverts, in terms of bridges, in terms of all those, we need to think in the long-term scenario, because we cannot, if we cannot rebuild the culvert again, we cannot rebuild the bridge. It's bridge itself has its own life of 100 years, for example. So this was what I wanted to say. Thank you. Okay. So as I just mentioned, coming back to wastewater, that this localized treatment. Okay, okay, this engineering and common sense also go hand in hand. Basically, there's a saying that nip the evil in the bud. So this is where this localized treatment is very very important. That okay, why we need to first accumulate all the wastewater and accumulate it and transfer it to a far off location, and then we treat it, and then from there on we use that treated effluent for some other purpose. So why not we just nip the evil in the bud? We just treat it then and there, and solve the problem at the very beginning. But anyway, this is something we need to start thinking as a community, and look forward to develop solutions towards this. Okay, so this is a wastewater network similar to all other networks. So we have our manholes and our pipes. So Again, for manholes, we need to define the depth in the design, because, okay, yeah, I just forgot to mention, this is a gravity network. Same, the stormwater is also gravity network. Okay, there are sometimes we need pressure lines, but potable water is a pressure line. But for gravity network, so this follows the force of gravity. So it needs to be sloped. And again, for sloping, again, we have to see how much deep we can go, because there are some, okay, we have a discharge point far off, so we cannot go very deep because this has own constructability issues and, maybe groundwater issue. So then again, we have to think that maybe we sometimes have lift stations, we need to raise it, and then again, we go by gravity. So these also, although generally, I mean, as an optimum design, we need to avoid lift station, because lift station has an operational and maintenance cost also. It needs continuous operation, electricity requirement, and so gravity system doesn't need that much overseeing. So if we can manage with gravity, that's very good. Okay, future sleeves. So okay, this is also I just mentioned here because not all utilities, anticipated utilities may be designed or may be constructed in one go. Like for example, some of the utility services, they are designed by the authorities themselves. For example, I can quote gas line. So gas line, generally they do it on their own. So if that's the case, and we cannot just keep waiting for them, maybe they come in future. So we need to provide corridors to them. Okay, corridor is fine. But again, they need to cross the roads also. And road is already built. So that, although it's I see that this is very unfortunate that in our country, we keep digging the roads, and the other issue is that even we leave it as it is. I don't know, in their contract, it's not there to reinstate the whole thing again to its previous position, but that's a big civic issue later on. So while designing, what we can do is that we need to provide those future sleeves, so that later on when that utility comes, they can they don't need to cut the road, so they can just simply go underneath, and thus their sleeve is available, so they can just cross that through that opening. And of course, we can provide sleeve, the utility markers there, sleeve markers there. And if not, even if we have the drawings available, so they can take hold of those drawings, because everything will be marked properly with the coordinates, so they can see where are the location. And even we can provide some future sleeves, some sleeves just to be used later on, because at that time sleeves, these are mainly PVC pipes, so that doesn't cost much. But if we have to go back again and cut the road, so that's a big thing. That's we should avoid. Just one positive thing also I want to share, that recently when I was there in Lahore, so this PTCL, so they are providing this fiber to home lines. So what I can very clearly see, that they have done a good job, because once they leave the area, so they leave it, they reinstate it to the previous condition. So you can see that it's very well done from the, I mean, it's the contract, I think, is, and I just discussed with them, by the way. So because there is another term used, which is called betterment. So there is always an issue if some utility comes and they dig the road, and then the authority, the operating authority, they say, okay, you should have done this, then in contract they sometimes mention that, okay, we will not do bettering. So whatever the as existing situation, we'll just reinstate to that. So I think I understood from them that they are also just reinstating to the previous situation. But ultimately, what I saw, that they left it in good shape, so which is good. Okay, so now these are just some layout showing some future sleeves, especially near junctions, because it's mainly where this line is going, and then it cross the junction here. Okay, so irrigation. So another wet service is irrigation, although Generally, we don't have irrigation. We just use water bowsers to irrigate our landscaped areas in our cities. But in other parts of the world, here we have the landscaping, this irrigation network along with all other water lines. And I just forgot there is a fire network also, but sometimes it's combined with the water network, but there can be separate fire network also, but this is also more or less on similar lines. But landscaping, okay, so we need to understand what is again the demand comes from the landscaping. So how much is the landscaping? So based on that, we need to design our irrigation system. And mostly this treated sewage effluent, which comes out from the sewage treatment plants, that is being used for irrigation purposes. So fresh water or potable water is not used for irrigation. So this is again a utilization of reuse of wastewater, which is quite good. This I just mentioned here. This is mainly not done by the infrastructure team. This tertiary irrigation or automated irrigation, this is mainly taken care of by the landscaping team, because this is very integrated with their landscape, with their design. So like all these sprinklers, bubblers, so these are being automated, so that efficient water usage is very efficient. So just based on the demand, so sometimes they operate based on the time, or based on even the moisture content available, based on the other conditions. So this is something I just mentioned here for being an interesting thing. So this is again irrigation layout, pipes and chambers. And again, because tree line is on both sides, so sometimes this distribution line you have to cross to the other side to have some tertiary system running along the other side of the road. Okay, now we just briefly discuss this electrical and telecom, because this is designed by our electrical and telecom brothers. But we just need to understand that again, this is a network. Again, this is a hierarchy. Again, we have extra high voltage lines, we have high voltage lines, we have low voltage lines, we have primary substations, we have 33 kV substations, we have 11 kV substations, we have package substations. So this we just need to understand, and we need to see that what duct arrangements is required, how their chambers fit in the overall picture, and of course the site locations for the substations. Okay, for larger substations, of course, as we are talking about small development, so we mainly have to deal with package substations or transformers, as we have just in our cities mainly this pad mounted transformers, but in other parts of the world we have the whole cabinet, enclosed cabinet with switch gears and transformers. So we have to allocate space in our master plan, in our urban plan, for all these facilities. Again, street lighting I just mentioned here. So this mainly is this, there can be a separate team, but basically this is being taken care by the electrical team. So based on road type, there is luminosity requirements, how much lux is required for a specific type of road. So based on that, we design our street lighting. There are the whole process, this softwares and everything. So this again is a network, and again there are some feeder pillars which needs to be located in a way that they don't have any problem with other, like even visibility issues or other issues. So this is where this whole integration and this interdisciplinary approach comes. So all steps needs to be integrated and all interdisciplinary checks need to be made. So we cannot work in isolation. That is very important and needs to be emphasized again and again. So this is again electrical network. So this is electrical line. So again, we have to have separate corridors for HV lines, for LV lines. Okay, EHV lines are mainly not part of this sort of this small developments. And again, this is how And again, even HV and LV lines, they need to be separated by a certain distance because there is some this electromagnetic issues. Okay, again, this is again interdisciplinary, and we need to work closely with our electrical team. So telecom. Okay, for us, telecom is mainly ducts and chambers. But again, there are a lot of services running along those lines. So I just mentioned few of these services: data and voice, or we can say internet services. Then security, CCTV, closed circuit television service. So that's also. So sometimes, because this fiber optic cable, so they can have a lot many channels. So this is just. But again, sometimes if the authority is different, then they want to have a separate. Even sometimes they go for a separate corridor also. Like for example, some military service, a military communication line. So they need to have a separate corridor for them. So this also we need to know well in advance so that later on we don't have such issues. But I mean, if it's being operated by one authority, then we can run various services on the same cable or same channel. I mean, various channels on the same cable. Building management system, how this is again how we are going towards more smart cities, smart buildings, so that and again I just briefly mentioned earlier that how we manage this demand and supply cycle. Okay, so this is where Rizwan Saab also raised a very pertinent question that okay, we have, because this demand keeps changing. So we need to also in a way change our work on the supply side also, so that make our system efficient. For that we need information coming back from the consumption side, from the building side, so that they both speak to each other, and then accordingly they can adjust the best way forward. And now it can be done in real time actually. So this is happening. And SCADA, supervisory control and data acquisition. So this is how we run our pump stations, our substations. Then PMS, power management system. Again, this information related to power and how we manage this supply side also based on the demand side. But again, for civil side, it again is just a duct network and chambers. And that's how generally we talk about, civil component of these services. So this is again telecom. For us, it's ducts, chambers, house connections. So mostly we just remain ignorant of what is inside those ducts. But it's always good to see what's happening and to have an holistic view of this whole situation. It always helps us to understand others' point of view, and then of course we can discuss and negotiate with them easily. This is the last layout. This just shows the composite utility layout where all the utilities are laid together. So this is where it helps us to understand all the clashes, all the issues. If some utility line is encroaching into other corridor, if some issue here or there, so we need to resolve it. And again, it's an interdisciplinary approach. We cannot do it, or one discipline cannot do it on its own. So he or she needs to understand the other's point of view, why he did like this. So we need to develop a common ground where everyone is happy at the end of the day. So a lot of interaction, a lot of interdisciplinary.
Aamir Saab,
Please.
I have to interrupt you here. Muslim Nawaz has asked two questions.
Please.
The first one I will ask after the end of the lecture, but the second one is pertinent at this stage. He's asking,
Right, sir.
what pressure, water pressure, how calculated for small activity? Would you like to answer it now? You can answer it.
What pressure is required for?
No, water pressure, how calculated for small activity?
You mean required water pressure or existing water pressure?
I think required water pressure.
Okay, so required water pressure, basically we see that at the consumption level, at the building level, what is the pressure required? Okay, so mainly, it's a single story building, it's a double story building, so we need 1 bar pressure, 1.5 bar pressure. So based on that, we can design our whole network, that okay, this is the required pressure. And if it's a high rise building, it's an overhead tank. And then again, it's not just, we need to maybe introduce new pumps into the system to reach to that pressure. But generally speaking, at a building level, 1 to 2 bar is sufficient, because we don't need extra pressure also, because that will also have some issues in terms of our we need to design our internal network to cater for that pressure. So our pipes may start bursting, so we need to again look into that thing. Okay, so from here we just finished the overall overview of this design process, or the design components for an infrastructure design. But there are just few slides related to the technologies which are shaping up this whole process now, and sooner than later, they are going to become norm. So people who are in this industry who remain ignorant to those, so they will be facing serious issues later on. So this is the same as I just mentioned earlier, that when we move from manual drafting to this computer drafting, computer assisted drafting, so the people who didn't learn that quickly, they really faced problems in the job market later on. So just I'm these three technologies are three things I want to mention here, which is BIM, building information modeling, CD, common data environment, and digital twin. So these are just you can say softwares which are related to these. Civil 3D is basically more for infrastructure works, and Revit mainly for building works, for structural design. And then the common data environment, we have like Autodesk Construction Cloud, mainly for models, for drawings, and project wise. It can be used for drawings as well, but mostly for documents. So just I'll go to this slide, which is BIM. So I'll just read it. Building information modeling is an integrated digital process of designing, constructing, and or operating a building or infrastructure asset using electronic object-oriented information throughout all project stages. So if you can see this picture, so this is a 3D model of infrastructure. You can see the pipes, you can see the chambers, you can see how this vertical, how this duct pipe vertically, the vertical design of this, so that, at here it goes below this line, at here it go above this line. So this way we can visualize during design what's happening to our design. We can identify all the clashes, we can resolve them quickly then and there. So from 2D design, now we are moving into 3D design and 3D modeling, basically, where every component of the design is modeled in 3D. And of course, then later on, we can extract drawings from the model only. We don't need to prepare drawings separately. So model is like our common truth for for all. So, and you know, all various disciplines, they produce their own sub models, like grading will prepare their model, roads will prepare their model, road team will prepare, storm drainage, water, and then these will be all integrated into one federated model, like the composite drawings we saw earlier. So there we can see, okay, what's happening to our service. I mean, they can be clash with the foundation of the street light pole. So is it good to move the chamber or move the street light pole? Okay, so there is issue. We cannot move the street light pole because it has to follow certain criteria. So can we move the chamber itself? So all these, again, interdisciplinary discussions. So interdisciplinary is key to resolve all those issues. So street light designer cannot move the street light pole on its own. But again, you know, there is some flexibility. If there is like gravity lines. So gravity lines are difficult to this change, you know, but pressure lines, okay, so pressure lines, we can go up, we can go down. So again, you know, there are some flexibility in some utilities, so we need to see that as well. But the main point is that now we are moving towards this sort of design. So 2D drawings are soon going to become part of history. So common data environment, I'll just read through first. A single source of information used to collect, manage, and exchange project documents consisting of various forms of information, such as models, drawings, schedules, etc. Facilitating collaboration between project team members helps to avoid duplication and mistakes. Depending on the project requirements, a range of processes, practices, and technologies may be required to facilitate collaboration and act as a common data environment. So what was happening previously? Okay, there is a client, there is a manager, there is a designer. So each one is talking to other one, you know, independently without the third party knowing what's happening. So this was our traditional information sharing model. Now with common data environment, we have all information available at a common platform. So each one can access. Of course, there are, you know, accessibility rights. So someone can only read, someone can modify. But again, you know, this information is available to people. So they can see what's happening. So we don't need to hide anything. Okay. So have all thing, there is a common truth, you know, available to everyone. Okay. If there is any change happening by one discipline, so all will know that, okay, someone has changed. Okay. Then of course its impact, he cannot change, he or she cannot change on its own. So he need to inform others that, okay, this is the change, what would be the impact for all other utilities, for all other disciplines. But again, you know, there is a common data environment, everyone can see. Of course, we need to have, you know, interdisciplinary coordination meetings, discussions separately, but information is available. So someone can go and check, okay, what's in the model, what's in the drawing, what's the schedule. So you don't need to ask other, okay, send me the latest drawing, because latest drawing, latest model is available. So this is also becoming, and even the client there is a transparency. Even the client can see, okay, well, how much progress we have made, what's being developed. So if there is an issue, he can straight away then and there tell us, okay, this is not in line with the scope of work. This is not in line with what I instructed you earlier. So this is happening, you know. So we again, you know, as I just said earlier, so now we cannot work in silos because everything is open, clear, and transparent. So we just need to be transparent as well. And if there is any issue, we cannot hide it. We need to come up front. We need to escalate it. We need to tell others, okay, because of this reason, because we have to have, you know, enough justification of any change, and we need to try to, at the initial stages, try to understand the whole thing holistically, so that later on there are no these surprise changes happening. Now this digital twin. So digital twin, because this is again an emerging technology, so there are no like an agreed upon definition, understanding of what is a digital twin. So I just copied from a this reference PwC, and this is a very good description. But in nutshell, basically, okay, we have a 3D model of our design. So we introduce our, we add additional layers to that model. We introduce our, how we are going to construct it. So from that point of view, also we can add additional layers so that, we can keep reviewing the model, how it's being constructed. So we can check how much is being constructed and how much is still remaining. And again, we during operation also we can add policies and we can check those policies, what is the impact happening on the system. So it's like a digital copy of the reality. So it's a digital twin of the real physical thing. So I'll just read it again from this slide. A 3D digital model connected in real time to a real physical asset, replacing as-built drawings with as it is. So this is the key. So it is connected to real time. Okay. So what's happening on the system? So we can readily observe it on the digital twin and see its impact. And then we of course mitigate that impact. We can look into the solutions. So I'll also just briefly, I'll just read it through because it's very important that, okay, these are various stages of development of a digital twin. So descriptive analysis. So we visualize the city in 3D. Okay, I just want to say something here also that, okay, we were used to have 2D drawings, but of course we all know that these 2D drawings are for a 3D thing. But as an engineers, we develop good analytical skills, but at the same time, because we were dealing with 2D drawings of a 3D object, so we are good at visualizing 3D object just looking at 2D drawings. But now maybe we can visualize it better because even the 3D model is there in front of us. So we don't need to okay, maybe that's more developed, I don't know. But again, that facility will help us. But now we have a 3D model which even a layman can see what's happening. But previously, that was only for a layman, it was difficult to understand from 2D drawings how this will look into 3 dimensions. But now, I mean, it's anyone can see it. So it's very transparent. So we need to be now very careful in how we do it and what we do it. So again, just going back to this slide, visualize the city in 3D and to its changes over time, such as new assets, roads and bridges, movement of people, demographic and economic changes. All there is an existing development. So what are the changes being made? So we can see by having a digital twin. Then predictive modeling. So models predict and forecast underlying activities in sectors such as real estate, transport, sustainability, and socio-economic sector. So we can predict, we can do modeling, and we can see, in real time how this will impact the physical asset. So again, this is a scenario planning. So we can run various scenarios. We can plan, okay, if we do like this, what will happen? What if scenarios we can run? If we do like this, or what's going to be the impact? So this sort of things will happen. I mean, we can utilize this digital twin for that. And then of course, operational excellence. Okay, we basically today discussed about design, but again, there is a lot of interaction will happen in design, construction, and operation. So we need to consider even during the design stage, the construction issues, constructability issues, and operational issues. So this is becoming very comprehensive now. And because of these technologies, so we can share this information well ahead with the construction team, with the operational team, and take their feedback and, accordingly, update our design. So improve operations by making the organization proactive through the command centers and AI-powered recommendations backed by real-time data integration. So this is something, okay, we started from very basic needs, but now technology is helping us to optimize it, to rationalize it, to have efficient use of our resources. And now it's up to us that we learn these technologies, we make use of these technologies which are available. We only need to incorporate them in our discipline, and which will help us in long term to have better designs, to have optimum design, and to help our civilization grow towards progress in a better way. So that's all from for this lecture today. Thank you very much for your patience, and I hope this was a good utilization of your time. Now we can have Tahir Saab, we have some time left.
Yes, Ji, thank you very much for delivering a lecture on infrastructure development that provided profound insights on the subject discussed by you.
Thank you very much.
Now we have some questions here. Let me start with the one that I left. Is from Muazzam Nawaz. His first question. Well, his first question is in fact a comment itself. I don't know, would you like to answer it or not?
Please,
I'll
please.
read out the question. It is, this lecture is applicable in UAE or Gulf, not in our part Pakistan. What would you say by guest speaker, please? Can you answer it?
Is he mentioning about some specific discipline, or it's general?
No, he's saying the overall lecture, whatever
Okay.
you have deliberated.
I
It is not applicable in
I think
Pakistan.
these are quite universal. I mean, this is nothing related to, okay, maybe because of, as I just mentioned, because of the a lack of capital, maybe we are not doing something. But I mean, if like, for example, okay, for power lines, for example, we have like overhead lines in most part of the city. But again, in certain developments, we can see now that they are going underground. Okay, see, as I said, sewage treatment plants, okay, because it's a capital intensive thing. So, and again, I know that we are, and there have been some discussions at government level to do it with public private partnership basis. But these are very universal things. This is civil engineering. This is applicable to, and that's why I try to keep it general. I didn't mention any specific code or standard or guideline. So I think this applies to Pakistan as well as it applies to UAE or any other part of the world.
Yeah, thank you. In any case, I mean, if something is not going on in Pakistan, it doesn't mean that we should not discuss it. We should not spread the knowledge. By learning, things start moving and we start applying them. Anyhow, now the next question is from Aksa Batul. She is asking, in the backdrop of global warming, apparently the forecast of future hydrology in the light of past hydrological data is no longer reliable. What are the available options now?
Yeah, it's a very good question. Okay, so I mean, we cannot see the future actually, so we have to rely on history, on the past. But what people are doing right now, just they are using some climate change factor in while they are determining the flows or so they are just factoring it, like in structure we provide factor of safety, so they are just multiplying it like 1.1 times, 1.2 times, just to have this but I think again this is something we need to understand more clearly. Okay, the climate change, how it's going to impact, and of course there is a talk about resilience infrastructure also, that okay, there is a storm event, and then how quickly we can go back to the normal situation. Human life is very important, so we should ensure that in case any such storm event, we need to ensure that there are proper system available to safeguard human life. Of course, if there is a damage to property or to infrastructure, so that we can reconstruct later on. But again, there is a talk about resiliency now that uh, this infrastructure should be resilient. And that's where, I feel that young engineers like Aksa can start looking into these things, and maybe come up with the answer to her own question later on.
Okay, thank you very much. The next question, incidentally, is again from Ms. Batul, Aksa Batul. I note that inclusive design of road cross sections does not appear to be on anyone's agenda in Pakistan. You are yourself Pakistani. Do you think it is capacity problem on part of the planners, or do we still need more awareness at the social level?
Okay, I think this is not that technical question. So mainly I would prefer to let it pass. But just I would say that from engineering point of view, I mean, we actually have a role to play actually. Okay, so there may be some administrative pressures, but as an engineer, we in our capacity, whatever it is, we need to tell the truth. I mean, we need to advise. Okay, maybe our advice is not being taken that seriously, but still we need to keep moving in that direction. And okay, I mean, we just want to show something. We want to show some physical infrastructure, visible infrastructure. But again, again, I don't want to comment on the political because these are all politically motivated. But as an engineer, I think we also need to focus on our responsibility. We need to, because as we know that this is not the right way, then in our capacity we need to keep highlighting it. So I think that's the only way. I mean, what else we can do?
Okay, thank you very much. Now we have a question from Shahdev Khalid. I'm not sure whether this question is very much related to the lecture, but let me ask you. And considering the variability of soil conditions across different project cities, how do you tailor your geotechnical design approach to account for regional geological differences and site-specific challenges? Well,
Okay,
what do
basically,
you say?
okay, this is a very geotechnical related question.
Yes,
But
that was
our
my point.
lecture was mainly related to infrastructure, and for infrastructure we mainly talk about pavement design, where we need the CBR value from the
Yes, exactly.
geotechnical report. Okay, there may be some variation in CBR value for the if it's a large area. And again, we can go for the as a safe bet, we can go for the lowest value, or we can do some compartmentalization if it's a large area, and then we can based on the CBR values, we can do our design for certain area based on certain CBR, and for another area for another CBR. So I think that's what we can do. But for, I mean, it's a very it requires some so it's I think maybe I'm not the right person to answer it in detail.
Right, sir, I agree. So we have a comment from Rizwan Mirza. I will leave that comment for the end, and I will ask Rizwan Mirza to, who is also my co-host, to dilate more on his comment later at the end. Before that, Muslim Nawaz has asked the question, that is, road accidents are quite frequent in our part. Does it is failure of road design or vehicle individual's mistake? Comment on it for better understanding.
Okay, so if we see the crux of this whole discussion, that I think this is a very good question. We need to think holistically, And I think this question leads us towards that. Okay, if it's a road fault or a driver fault or a mechanical fault, so this is a whole system, you know. There is a road component, there is a driver, which is a human, human aspect. Then there is a mechanical equipment, this vehicle itself. So all this interplay in this system. So the clash could happen because of any coordination issue, as well as any malfunctioning of the of one of these components as well. So it can be a mechanical failure of the vehicle. And again, we are not very, I mean, I'm talking about Pakistan, we are not very good at this fitness, ensuring fitness of our vehicles at a personal level. Also, we only go to the workshop when our just car dies down, basically. And then a human, of course, because this is where we come up with the driver behavior. So driver behavior is something we need to learn. And when the authority, whoever is responsible for issuing licenses, so he I mean, that authority should ensure that that the license is being issued to a person who has a, I mean, who will behave uh, but of course, behavior is not just related to me. I mean, it's something, it's I learn from the environment also to behave. So this is something, uh, this is a very systematic, this needs to be addressed at a system level, to have proper you know like procedure to ensure that people behave properly. There should be some checks and balances, some, what we call some, there should be proper fine if you don't behave. And similarly, the road, okay, of course, road has a very critical part to play with. So sometimes it's a long time back, we there was a, I mean, we discussed, I mean, Rizwan Sahib and myself discussed about some issue happened on motorway. So this is basically still okay, because of just we were lack of funds maybe at that time. So we, in order to save money, we went for an we reduced the design speed for a particular stretch. And that is basically because if you are following a certain speed, or all of a sudden you have to reduce. So these there are road related issues, road design related issues also. So again, we need to apply a holistic approach, and hopefully, we can start improving things.
Okay, Ji, thank you very much. This was the last question, and now Rizwan has given a comment that I think each part of the lecture is fully applicable to Pakistan. So he is also the co-host here. So I would like him to throw some light on what he has written, and inshallah, after that we will conclude the lecture. Rizwan, please go ahead.
I think there has been some misunderstanding on the part of the person who asked the question. As a designer and as a consulting engineer, I think whatever Mr. Aamir has said is standard textbook, internationally recognized, practice-based thing. There is nothing theoretical or academic about it. It is what there is in practice in Pakistan on all good projects. So even the BIM part is being practiced here. So if on certain government projects we are not adopting certain practices, we can't say that the lecture is not applicable. We should adhere to what is the right way of doing it. So I must thank him. I am really myself, I enjoyed the lecture. It was very concentrated. He touched upon everything, almost everything. Although
Thank you very much.
covered so much that it may not have been possible for everyone to fully understand it. but it strikes a chord. Thank you so much, really.
Thank you very much, sir. Thank you.
So, ladies and gentlemen, now we have come to the end of this program. And I again thank our guest speaker, Aamir Sahab, very much for his deep insight that he has provided on the infrastructure development. And I hope you have enjoyed the lecture as much as I have in sitting here in PSC's office. And I must appreciate that though the lecture was, in my view, very simple and very, in a way, I think in the back of our mind, as a common sense, we knew all these things. But Aamir Sahab has sequenced the lecture very well. It made the topic very easy to understand. So as Rizwan has said, I mean, we should thank him for such a brilliant lecture. And I hope we will see Aamir Sahab again on the same topic, specifically choosing any infrastructure subject and dilating on that subject more. Now, what I have to say is the next lecture, number 67, would be on 15th June 2024. The topic is managing construction contracts, and my co-host Rizwan Mirza would be the guest speaker on 15th June, lecture number 67, topic managing construction contracts. So kindly note it, and those of you who are interested in managing construction contracts, kindly attend the lecture. And those who desire to get the CPD points, they can officially register for the lecture. Now, those who have attended today, their certificates would be ready from 16th of May, that is Thursday, and you can collect them from 14A1 Block P, Model Town Extension, Lahore. And the person before coming to collect the certificate, if you want to contact somebody, it is Ahmed Akram, and his phone number is 0347 462 5111. Ahmed Akram, and I repeat the cell number 0347 462 5111. And Aamir Sahab, inshallah, your shield and your certificate would be dispatched by courier mail and should be with you in a week or 10 days, inshallah, from today.
Thank you very much.
And now, before I conclude, I would like to express my thanks to my staff here, Sadia Naveed and Hasnan, who worked in the background to make this transmission as efficient as possible. So thank you very much. Allah bless you all. I will see you, inshallah, on 15th June. Thank you very much. Allah Hafiz.
Thank you.